Okay, so today we're actually going to start talking about prime factorization with exponents. Our essential question is looking at how do we find the prime factorization of a number. So like most of our lessons, we're going to start with the vocabulary terms. This lesson is coming from your textbook, so we're looking at page 511, and we'll actually take some notes in our journal first, and then we'll go to the textbook, okay? But vocabulary is important, and if you don't understand the vocabulary terms, then you're going to have a hard time with the unit in general. So the first term we need to define are prime numbers. So we need to know what are prime numbers. So a prime number is a whole number I'm going to remind you, we're going to use that symbol again. So a whole number that has exactly two factors. One and itself. So we're going to take we're going to look at or list right here the first 25 prime numbers. Now this list can go on and on and on, so I'm only going to give you the first 25. I'm going to make a small pencil grid just so I can keep my numbers in order. You're writing a little smaller than normally. 1, 2, 3, 4, 5. And then just need to have those 5 columns. So those pencil grids are just to help me keep my numbers in order. So the first prime number is 2. Then we have 3, 5, 7, 11, 13, 17, 19, 23, 29. In case you're wondering, I don't have these memorized by heart. I am looking at a little chart that I have, but most people typically can remember the first 10. If you can remember past that, you're doing really, really good. But I'm just going to give you this list here so that as we're working on some of these example problems, you can quickly reference this list to determine if your number is prime or composite. So we have 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, and then 73, 79, 83, 89, and 97. So again, these are the first 25 prime numbers, and that means each of these numbers, the only factors that it has is 1 and the number itself. So the factors of 37 are 37 times 1. That makes them prime. Now we're going to look at the second type of number, which are composite numbers. So I'm going to list that term out here. Okay. So composite numbers are whole numbers, or is a whole number greater than 1 with more than 2 factors. So prime numbers only have 2 factors. Composite numbers have more than 2 factors. So let me give you an example of a composite number. 6, even 18, 9. These numbers can be broken down into more than 2 factors. So for example, if I take the number 6, the factors of 6 are 1 times 6 and 2 times 3. So there are 4 factors for 6. Okay, the factors would actually be 1, 2, 3, and 6. I could take 18 and do the same thing. If I break 18 down, we have 1 times 18 would equal 18. 2 times 9 would equal 18. And then 3 times 6. So 18 has 6 factors. Okay. If you wanted to see 9, 1 times 9 and 3 times 3 would equal 9. So if you have more than 2 factors, and each of these do, they're composite numbers. Okay, and this is important. You have to be able to tell the difference between a prime and a composite number when we're looking at prime factorization. So let's talk about what is prime factorization. Prime factorization, an easy way to think about it, it's breaking down a composite number. Okay, the mathematical description for it is this. It's a composite number written as a product of prime numbers. So I'm going to put in parentheses what I said just before that. It is breaking down composite numbers. Okay. So in 5th grade, you guys worked with prime factorization, and the way you broke down a composite number is you used a factor tree. So I'm going to show you what that factor tree is, or remind you of what a factor tree looks like or how we use it. And then we'll list the prime factorization the way you're used to seeing it in 5th grade, and then we'll list it with prime factorization using exponents. Okay, so a factor tree is nothing more than a diagram. It's a picture that we use. So I'm going to use the word model or picture. And we use that to find the prime factorization of a number. So if you remember back in 5th grade, you might have done something like this. I'm going to take 36, which is a composite number, okay, and we're going to break it down using a factor tree. So I'm going to just kind of zoom in on that section there. There are different ways to see it. I could say 6 times 6. And each time, every time you have what we're going to call branches from the tree, you have to determine, is the number at the end of the branch a prime number or a composite number? If it is prime, you're going to circle it. If it's a composite number, you have to continue to break it down. So 6 is a prime, or excuse me, 6 is not a prime number, so we can break it down some more. 2 times 3. Here it is again, 2 times 3. You don't want to have a 1. I won't break 2 down anymore because the only factors I have is 1 and 2. So because it's a prime number now, I'm going to circle that. And my prime factorization for this, for 36, just the prime factorization would be 2 times 2 times 3 times 3. Now this is what we wrote in 5th grade. In 6th grade, we're going to do the prime factorization with exponents. Okay, that's what my little shorthand is, prime factorization with exponents. So we have 2 as a base, and how many times does it repeat? 1, 2. Times, we have 3 as a base, it's a factor, and how many times does that number repeat? Twice as well. So the prime factorization with exponents for the number 36 is 2 to the second power times 3 to the second power. Okay. Now there's different ways, like I could have chosen 2 different numbers to break down 36 with. I could have used a 9 and a 4. This is a composite number, so I need to continue to break it down. And the 3's are prime, so I'll circle those. And then 4 breaks down to 2 times 2. Okay. But if you notice, look closely, the prime numbers are the same. I have 2 2's here, and I have 2 3's as well. And so the prime factorization is the same. So it doesn't matter what your initial factors are. When you finish breaking the number down, it should be the same. All right, so we're going to do a couple sample problems here. So on the opposite side of my journal, okay, so I'm just going to break down the number. Let me see if I can get it here. 120. Now I have to determine first, is this a prime or composite number? Okay. If you said it's composite, that is correct, which means you have to continue breaking this down. Trying to find my marker. So I need to look for 2 factors. And this would be a good point, a good place for you to pause it really quickly, for you to try this one on your own, and then come back and see if we have the same thing. Okay? So I'm going to use 12 and 10. That glare is right over that 12. Let's see if we can figure it out. Okay. Now, is 12 prime or composite? It was composite. So you got to break it down some more. I could use 4 and a 3. 4, oh, well, actually, 3 is a prime number. We'll circle that. 4 is not, so it needs to be broken down some more. We have 2 and 2. I'm going to go ahead and circle these now because 2 is a prime number. And we have 10. 10 can be broken down into a 5 times 2. So these are all prime numbers now. Notice that I didn't circle my composite numbers. I'm just circling the prime numbers. So I have 2 as a factor. And how many times does 2 repeat? 1, 2, 3. So 2 to the third power times, Actually, let me backtrack for a second. What you could do to make sure that you have it right is to list the factors. And every time we list the factors, we list them in order from least to greatest. So 2 times 2 times 2, there's a 3 and a 5. This first one is just prime factorization. Okay, so if we're doing it the 6th grade way, we should have 2 to the 3rd power. So notice I have the 3 2's, and then I have a 3 and a 5. Okay, this is how your final answer should be. This is prime factorization with exponents. Okay, so hopefully we got the same thing there. Now we're going to go ahead and go to our textbook, and we're going to work on an assignment from there. The textbook starts at page 511. It goes over, similar to what we did, vocabulary terms here. It has a list of numbers that you would match to their factors, so you can do that as some practice. There's a little real-world link here that's talking about Texas and what are the factors of 254. 254 is obviously much bigger than the numbers like a 2-digit number or a single-digit number, but you can try that one. Okay, then we're going to look at the next page. The next page just walks you through some examples. So it has examples of determining if the number is prime or composite, and then some sample problems here for you to try on your own. Remember, composite numbers have more than 2 factors, and prime numbers have only 1 factor. It further takes you into the prime factorization in a factor tree, which is what we did in our notes. So we kind of put it all together, but this has the examples so you can kind of go step by step. Looking at example 3, it has a factor tree here, and you're kind of filling in the blank for your practice. And you'll notice that 120 is the same number we did in our journal. Okay, and then here's a few more examples. So it has 36. I'm on the top of page 513 now, but number 4 here, the example is number 36, so it breaks it down, the process for you there. Number 5 and number 6. 5 and 6 have negative numbers. The process for them is the same. The only difference is at the very end, you would bring that negative number out front. We're actually going to use a -1, so it just kind of shows you that's the only time you're going to see 1 in a prime factorization. It's when you have a negative number, a negative composite number that you're breaking down. Okay, so down below they give you a few got it's here, D, E, F, and G, for you to try on your own. So I'd like you to go ahead and attempt to do those. And then for your class assignment, you're going to turn the page. This gives you one more example here. It's kind of using a table, so you can go through number 7 here. But I would like you to try numbers 1 through 7 on page 514. Okay. If you have questions or need to check your work that you tried on the back for those got it's, be sure to ask Ms. Trevino, or you can send me a post on our Google Classroom that says what your answers are, and I'll let you know if you got them right. Okay? All right.